A tsunami can travel across the open ocean faster than a jet plane, yet out at sea, it's often barely noticeable, sometimes under a meter tall. Here's what actually causes a wave that can flatten a coastline. Tsunamis aren't caused by wind, unlike ordinary ocean waves. They're caused by the sudden displacement of an enormous volume of water, and the most common trigger is an undersea earthquake. At subduction zones, where one tectonic plate is forced beneath another, the two plates can lock together and build up stress for decades or centuries. When that stress is finally released in what's called a megathrust earthquake, the seafloor itself can shift vertically by several meters in seconds, either lurching upward or dropping downward. That sudden vertical movement pushes the entire column of water above it, from seafloor to surface, either up or down almost instantly. The ocean has to respond to that disturbance, and it does so by radiating outward as a series of waves, a tsunami, spreading in every direction from the point of displacement. In the open ocean, a tsunami can travel at speeds over 700 kilometers an hour, but its wave height might only be a few tens of centimeters, which is why ships far out at sea often don't even notice one passing beneath them. The danger builds as the wave approaches shallow water near a coastline. As the seafloor rises, the wave is forced to slow down, and that lost energy gets converted into height, a process called shoaling. A wave that was barely visible in open water can grow into a wall of water several meters tall by the time it reaches shore. Earthquakes aren't the only trigger. Volcanic eruptions can generate tsunamis too, either through a sudden caldera collapse displacing water, as happened at Krakatoa in 1883, or through flank collapse, where part of a volcanic island slides into the sea, as happened at Anak Krakatau in 2018. Submarine landslides, where loose sediment on the continental slope suddenly gives way, can also displace enough water to generate a tsunami, even without any earthquake at all. Even rarer, a large meteorite impact in the ocean could theoretically do the same thing, though no such event has occurred in recorded history. Whatever the trigger, earthquake, eruption, landslide, or impact, the underlying cause is always the same: a massive, sudden shift in the seafloor or coastline that the ocean above it has no choice but to react to. If you want to understand how the world's landscapes were really made, subscribe for more landform explainer videos.